Lessons of Physical Geography. Chapter 3. Interior of the Earth. This chapter deals with 1. Sources of information about the Earth interior. 2. Direct sources. 3. Indirect sources. 4. Earthquake. 5. Earthquake waves. 6. Propagation of earthquake waves. 7. Emergence of shadow zone. 8. Types of earthquakes. 9. Effects of earthquakes. 10. Structure of the earth. 11. The crust. 12. The mantle. 13. The core. 14. Volcanoes and volcanic landforms. 15. Types of volcanoes. 16. Shield volcano. 17. Composite volcanoes. 18. Caldera. 19. Flood basalt provinces. 20. Mid-ocean ridge volcanoes. 21. Volcanic landforms, intrusive forms, tectonic rocks, batholiths, coliths, hills and dikes. Sources of information about the Earth's interior. 1. There are two sources for information about interior of the Earth. Direct sources and B. Indirect sources. Direct sources, meaning drilling and volcanic eruption, are examples of direct sources. During the process of mining and drilling, rocks and minerals are extracted, which gives information that there are layer system in the crust. Crust is made of many kinds of rocks and minerals. Volcanic eruption suggests there is some zone inside the earth which is very hot and in liquid condition. Direct sources are not very reliable because mining and drilling can be done only up to some depth only. 3. Indirect sources, seismic waves, gravitational field, magnetic field, falling meteors, etc. are examples of indirect sources. They are very important for know about Earth's interior. Movement of seismic waves suggests there are 3 layers in the Earth and each layer has different density. Density increases toward the center of the Earth. Movement of seismic waves suggests 2 things. There are 3 layers in the Earth and B. Layer has different density which increases toward the center of the earth. Earthquake is the shaking of the earth, natural event. It is caused due to release of energy which generates waves that travel to all directions. Why does earth shake? Release of energy occurs along the fault line. Rocks along the fault tend to move in opposite directions. As the overlying strata press them, the friction locks them together. However, the tendency of movement overcomes the friction. As a result, rocks get deformed. They slide over another. The result, energy releases. Energy waves travel in all directions. Point where energy releases is called focus hypocenter. Above the focus point on the surface, it is called epicenter. Earthquake waves. All earthquakes take place in the lithosphere, 100 kilometers depth. An instrument called seismograph records the waves. Earthquake and seismic waves. Meaning of earthquake. Then movement or vibration on the Earth's surface is called earthquake. In other words, then release of energy due to tectonic activity is called earthquake. An earthquake may be produced due to movement of plates, rising of magma, folding and faulting, violent volcanic eruption, etc. When earthquake occurs, three types of wave are produced called as seismic waves. These are P or primary wave, or secondary wave, C or long or surface wave. 1P and S waves are combinedly called as body wave as they move inside the body of the Earth. 2P wave is the fastest wave. It is also called as longitudinal wave. These waves move forth and back. In other words, waves move parallel to the direction of wave. These waves can move in both solid and liquid. 3S wave is slower than P wave. It is also called as transverse wave. It moves perpendicular to the direction of the wave. These waves move only in solid and disappear in liquid. 4L wave is the slowest wave. It moves on the Earth's surface. It causes maximum destruction on the Earth's surface. 5 focus point inside the Earth's surface from where an earthquake starts. It is already hidden inside the Earth. Focus of an earthquake may be found at the depth of 100 to 200 kilometers. 6. Epicenter. It is a point on the Earth's surface which records the seismic waves for the first time. Maximum destruction from an earthquake is caused on the epicenter. Epicenter is located just perpendicular to the focus. 7P and S waves are called as body wave. 8P wave can pass through both solid and liquid. S wave can pass only through solid. 9. Seismograph is an instrument which records seismic waves on a paper. 10. Richter scale is a scale which measures the magnitude of an earthquake. In other words, energy released by an earthquake is measured on Richter scale. Generally, it is from 0 to 10. An earthquake measuring 6 on Richter scale is 10 times more stronger than 5 and 100 times more stronger than 4. 11. Crust and upper part of the mantle is called lithosphere. 12. The opening through which magma comes out from a volcano is called as mouth or crater. When crater is collapsed due to a violent explosion, it is called as caldera. 13. Midoceanic ridge. Plates move away from each other under the water of the ocean and magma rises up. Form a long hill-like landform called as Midoceanic ridge. Midoceanic ridge of Atlantic Ocean is the best example. 14. Mercalli scale was developed by an Italian seismologist. It measures the destruction caused by an earthquake. It ranges from 1 to 12. Effects of earthquake. A. Ground shaking. B. Destruction to houses and buildings. C. Landslide and tsunami. E. Soil liquefaction. Solid soil becomes liquid. E. Damage to dams and reservoirs. F. Fire accidents. G. Destruction to transport and communication lines. Shadow zones and their formation. Meaning of shadow zone: an earthquake takes place. The places on the Earth's surface do not record the seismic waves. There are some zones where seismic waves, and waves, not reach during an earthquake. It is called as shadow zone. Shadow zones are formed due to two reasons. A. Three layers in the earth. B. Varying density of each layer. C. Liquid condition of the mantle. 1. P-wave shadow zone. Ideally, seismic waves should move in straight line, but due to varying density of layer, P-wave moves in a curved path. Due to this, an area around the Earth does not record P-wave. This zone is from 1050 to 1450 from the focus. S-wave shadow zone is larger zone than P-wave shadow zone. Developed because S-wave does not pass through liquid mantle of the Earth. Therefore, the zone from 1050 all around the Earth from the focus is called as S-wave shadow zone. Seismograph. Types of earthquake waves. 1. Body waves. 1.1 P waves. 1.2 S waves. 2. Surface waves. 0.1 Love waves. 0.2 Rayleigh waves. Body waves generated due to energy generated in the Earth's interior. Interact with the surface rocks and generate other waves called surface waves. Velocity of the waves changes along with the density of material. So the material higher the velocity. The direction also changes according to the density of the material. Propagation of earthquake waves. When they travel in the body, they vibrate the bodies of the rocks. The waves vibrate parallel to their direction of the movement. It led to the density difference in the material due to stretching and squeezing. The three waves vibrate perpendicular to their direction. Create troughs and crests over the surface. Emergence of shadow zone. Where earthquake waves are not reported, such zones are called earthquake shadow zones. It is observed that seismographs located beyond 103 degrees from the epicenter do not record the earthquakes. Seismographs located beyond 142 degrees again record P waves only. The entire zone beyond 142 degrees do not receive S waves. Shadow zone of S waves is much larger than the P waves. It is equal to 40% of the Earth's surface. Types of earthquakes. Magnitude of most earthquakes is measured on the Richter scale, invented by Charles F. Richter in 1934. Richter magnitude is calculated from the amplitude of the largest seismic wave recorded for the earthquake, no matter what type of wave was the strongest. Richter magnitudes are based on a logarithmic scale, is 10. What this means is that for each whole number you go up on the Richter scale, amplitude of the ground motion recorded by a seismograph goes up 10 times. Using this scale, A magnitude 5 earthquake would result in 10 times the level of ground shaking as a magnitude 4 earthquake, and 32 times as much energy would be released. Give you an idea how these numbers can add up. Think of it in terms of the energy released by explosives. Magnitude 1 seismic wave releases as much energy as blowing up 6 ounces of TNT. Magnitude 8 earthquake releases as much energy as detonating 6 million tons of TNT. Impressive. Fortunately, most of the earthquakes that occur each year are magnitude 2.5 or less, too small to be felt by most people. Richter magnitude scale can be used to describe earthquakes so small that they are expressed in negative numbers. Scale also has no upper limit, so it can describe earthquakes of unimaginable and, so far, experienced intensity, such as magnitude 10.0 and beyond. Although Richter originally proposed this way of measuring an earthquake's size, he only used a certain type of seismograph and measured shallow earthquakes in Southern California. Scientists have now made other magnitude scales, all calibrated to Richter's original method, use a variety of seismographs, and measure the depths of earthquakes of all sizes. Mercalli. Scale. Here is a table describing the magnitudes of earthquakes, effects, the estimated number of those earthquakes that occur each year. First 6 listed above have some hearings upon landforms, while others may be considered the effects causing immediate concern to the life and properties of people in the region. Tsunami occurs when the epicenter is below the ocean floor with sufficient magnitude. Tsunamis are waves generated by the tremors, not by the earthquake. Magnitude should be more than 5 in Richter scale. The earthquakes of magnitude 8 plus are rare, occurs once in 1 to 2 years. Tiny types occur every minute. Structure of the earth. Imagine a scorched egg. 1. The outer shell of the earth is called the crust, breadcrumbs. 2. The next layer is called the mantle, sausage meat. 3. The next layer is the liquid outer core, white. 4. The middle bit is called the solid inner core, yolk. Deepest anyone has drilled into the earth is around 12 kilometers. I have only scratched the surface. How do we know what's going on deep underground? There are lots of clues. 1. The overall density of the earth is much higher than the density of the rocks we find in the crust. This tells us that the inside must be made of something much denser than rock. Meteorites, created at the same time as the Earth, 4.6 billion years ago, have been analyzed. Commonest type is called a chondrite, and they contain iron, silicon, magnesium, and oxygen. Others contain iron and nickel. Meteorite has roughly the same density as the whole Earth. Meteorite minus its iron has a density roughly the same as mantle rock, example, mineral called olivine. 3. Iron and nickel are both dense and magnetic. 4. Scientists can follow the path of seismic waves from earthquakes as they travel through the earth. Inner core of the earth appears to be solid whilst the outer core is liquid. Waves do not travel through liquids. Mantle is mainly solid as it is under extreme pressure. See below. We know that the mantle rocks are under extreme pressure. Diamond is made from carbon deposits and is created in rocks that come from depths of 150 to 300 kilometers that have been squeezed under massive pressures. 5. The Earth is sphere. As is the Scotch egg, the diameter of about 12,700 kilometers. As we go deeper and deeper into the earth, the temperature and pressure rises. Core temperature is believed to be an incredible 5,000 to 6,000 degrees Celsius. 6. The crust is very thin, average 20 kilometers. This does not sound very thin, but if you were to imagine the earth as a football, crust would be about 1 by 2 millimeter thick. Thinnest parts are under the oceans. Oceanic crust go to a depth of roughly 10 kilometers. Thickest parts are the continents. Continental crust extend down to 35 kilometers on average. Continental crust in the Himalayas is some 75 kilometers deep. 7. The mantle is the layer beneath the crust which extends about halfway to the center. It's made of solid rock and behaves like an extremely viscous liquid. This is the tricky bit. The mantle is a solid which flows. Convection of heat from the center of the earth is what ultimately drives the movement of the tectonic plates and cause mountains to rise. Click here for more details. The outer core is the layer beneath the mantle. It is made of liquid iron and nickel. Complex convection currents give rise to a dynamo effect which is responsible for the Earth's magnetic field. 8. The inner core is the bit in the middle. It is made of solid iron and nickel. Temperatures in the core are thought to be in the region of 5,000–6,000 degrees Celsius, and it's solid due to the massive pressure. Earth's structure. Crust, the outermost solid part. 1. Brittle in nature. 2. Thickness is 5 kilometers. Thin under the oceans and thick under the continents. 3. 30 kilometers under oceans and 70 kilometers under mountains. Density in the ocean floor is 3 gram per centimeter cube. Salt density is 2.7 gram per centimeter cube. Mantle. 1. Second layer from the top of the earth. It extends from Mohodis continuity to a depth of 2,900 kilometers. 3. The upper portion of the mantle is called asthenosphere. Astheno is equal to weak. It extends up to 400 kilometers. 4. It is the source of magma. 5. Average density is 3.4 gram per centimeter cube. 6. Crust and uppermost part of the mantle is called lithosphere. Thickness is 10 to 200 kilometers. 7. Lower mantle is in solid state. Core. 1. It extends from 2,900 km to 6,300 km depth. 2. Outer core is liquid while inner core is solid. 3. Outer core density is 5 gram per centimeter cube. Inner core is 13 gram per centimeter cube. 4. Made of heavy metals such as nickel and iron. 5. It is also called as knife. Volcano is place where gases, ashes and a molten rock material lava escape to the ground. Active volcano Mount Pinatubo, Philippines in 1991. Lava from metric ton kilo pouring into the ocean during the sunset. Differences between active, dormant, and extinct volcanoes. Active volcano, the volcano that is currently erupting or shows signs of unrest activities, like earthquake activity or significant amounts of gas discharged. It is a volcano that is not presently erupting, has erupted in the past, is considered likely to do erupt in the future again. One of the dormant volcanoes in the Cascades in the Three Sisters area. Dormant. These volcanoes are also called sleeping volcanoes because it is presently inactive. It could erupt again. For example, majority of the Cascade volcanoes are believed to be dormant rather than extinct. This is an aerial view of Crater Lake in Oregon. Extinct, the volcano that is presently not erupting. It is unlikely to do so for a very long time in the future. Classification of volcanoes based on nature of eruption and landforms developed on the surface. Shield volcano. One largest of volcanoes. Two Hawaiian Islands are best examples. 3. Basalt lava flow. 4. Lava is very fluid. 5. They are not steep. 6. They become explosive when water is held in torrent. 7. Develops into cinder cone. Composite volcanoes. 1. Cool and more viscous lava. 2. Explosive eruptions. 3. They erupt pyroclastic and ashes along with lava. 4. Layers are formed. Caldera. 1. These are the most explosive type of volcanoes. 2. They collapse themselves and form into lakes. 3. The magma chamber is huge and found nearby. Flood basalt provinces. 1. Consists of highly fluid lava. 2. Some parts of the world are covered by thousands of square kilometers of basalt. 3. There can be series of flows. 4. The average thickness is more than 50 kilometers. 5. Individual flow is 100 of square kilometer. 6. Example. Deccan Plateau. And oceanic ridges volcanoes. 1. Found in oceanic surfaces. 2. More than 70,000 kilometers length. 3. Frequent volcanic eruptions. 4. Example. The Atlantic Ridge. Intrusive volcanic landforms. 1. When volcanic eruption takes place, some lava comes out and some settle down in the lithosphere. 2. When lava comes out, forms volcanic rocks. Some part cools down in the lower portion, forms plutonic rocks. Intrusive forms occur inside the crust. Batholith. Large part of the magma material that cools in the deeper depth of the crust. They are dome-shaped for large areas. They come out when erosion takes place. They are granite bodies. Bacoliths. Large dome-shaped intrusive bodies. Consists of level bodies connected through pipe-like conduit from below. It resembles composite volcanoes found deeper depths. They are localized source of lava. Example: Natka Plateau, apolites,